Hi guys. All right, at this point we've gone through everything with equilibrium, the definition, our stresses, our shifts, and the result of the shifts. Now we're just going to wrap up the topic with the idea of spontaneous reactions. At the top of this page in your notes, you have a review on entropy, which is disorder or disorganization. We know that solids have the least entropy and gases have the highest entropy. Also, dissolving something in water causes the entropy to increase. This is an important idea because you will be predicting reactions that are going to be spontaneous. So spontaneous and non-spontaneous reactions are describing a reaction and whether or not they need help in order to take place. So a spontaneous reaction is something that takes place without outside intervention, which means maybe you just put two chemicals together and they will react. You don't have to heat them up, you don't have to mix them, you don't have to add a catalyst. The reaction just takes place. Non-spontaneous is a reaction that requires some type of outside intervention. So maybe you will have to mix it up or shake it or heat it in order to get that reaction to proceed. So what types of reactions are spontaneous? What are the types of reactions that will just happen? Well, if you remember from earlier in the year, we talked about how chemical reactions would like to go towards a state that is low energy and high entropy. Okay, remember lazy and messy? That's what we're looking for. So if we are dealing with something going towards a low energy state, that is an exothermic reaction. Exothermic reactions release energy and they go to that lower energy state. So if you remember from kinetics, this was our exothermic potential energy diagram, showing that the products have a lower amount of energy than the reactants. Also, reactions increase in entropy. So you have that increase in disorganization. And that is the high entropy. So anytime you have a solid going to a liquid, going to a gas, or you have a solid being dissolved and making an aqueous solution, that will also increase entropy. Okay, so now the last idea for equilibrium is using table J. And we use table J to predict if a reaction will be spontaneous or not. And most importantly, we're predicting single replacement reactions. So in a single replacement reaction, a single element replaces an element in a compound that it's reacting with. So I'm going to give you an example here. Let's take the metal, let's take calcium. Potassium. And let's add that to a sodium chloride salt solution. All right. And when you have that single replacement reaction, if you remember, the single element will replace the another element in that compound. So we have a metal and we have a metal. The metals trade places. So if you remember, we talked about the cations trading places, or if it was something that was negative, it would be with the anion. So now the K will be bonded with the chloride, and that will go into solution, and the sodium will be on its own. So now we want to predict if this particular reaction can take place. Is it spontaneous? Okay, we want to know, is this reaction spontaneous? And the answer is yes. And let me show you why. Okay, the answer is that it will be spontaneous. So I have here table J. Now, table J is called the activity series. And we're going to first start with the series on the left-hand side, which is metals. There's one thing here that is not a metal, and you'll find that when you do the worksheet. So now the metals that we just had in our reaction were potassium and sodium. Here's the rule. If the single element in a single replacement reaction is more active than the element it would be replacing in the compound, the reaction is spontaneous. So when I take a look and compare potassium to sodium, potassium is in fact more active. The more active metals are listed at the top. So since potassium is more active than sodium, potassium will kick out the sodium and replace it. Okay, so that potassium will take the place of the sodium. That's why it is spontaneous. So you have the description right here. When the single element in a single replacement reaction is more active than the element or the ion in the compounds, the reaction is spontaneous. So again, potassium is more active than sodium, therefore it will replace it. So yes, it is a spontaneous reaction, and we're going to say why. K is more active than Na. Okay, K is more active than Na. And that's why we get that spontaneity. You can also see that on the right-hand side, we have some nonmetals. We have our halogens listed there. So we can also have a reaction where a nonmetal gets replaced. So if I were to give you an example of that, it would look something like this. All right, let's say we have Br2 plus calcium chloride, and we have BaCl2 plus, calcium bromide plus Cl2. So now since we're dealing with nonmetals here, this will take the place of that. We can see bromine is now bonded with the calcium and the chlorine is now off on its own. So will this be spontaneous? Well, let's take a look. This can only be spontaneous if bromine is more active than chlorine. So when I take a look at this, I have bromine just under chlorine. So bromine is less active than chlorine. This reaction is not spontaneous. Okay, and the reason why? Br2 is less active than Cl2. Okay, so in order for that reaction to be spontaneous, that single metal has to be more active than the metal or the nonmetal. That single element has to be more active than the element it would be replacing in that compound. Okay, now you have the Table J activity series worksheet that's posted as well, and you're going to submit your answers for that. Please make sure whenever you complete an assignment, whether it's submitted or not, you always mark everything as done on a daily basis. And also you might have seen that there is now a new sign-in sheet that's posted at the top of the page. Please fill that out each time you log into the class. Basically, it's like taking attendance. So you just quickly type your name in, click on the class, and submit. It takes 20 seconds, not even. All right? Any questions, guys? Let me know. Otherwise, take a look at that worksheet, get that completed, and get that turned in. Take care, guys. Talk to you soon.